Good whatever time of the day you're watching this, and welcome back to our math videos. Now, welcome back to solving multi-step equations. Before, when we had simple equations, it was oh so easy, and now we are just dipping our toes into the big world of multi-step equations. Now, I want to bring your attention to the key idea. Solving multi-step equations means to solve multi-step equations, you use inverse operations to isolate the variable. Now, we've been doing this. The only issue with this is figuring out what to do first. So I hope the more we do, the more you can start to recognize a pattern, especially after yesterday's video, that the first thing we do is simplify, then we go to addition and subtraction, and then multiplication and division, and by that time you should have your variable all by its little lonesome. So let's do some examples, and then you'll have some on your own problems you'll get to do in order to practice this for your very self. Now, I want to break this down for you as we figure this out. Let's look at this tree. If we were to think about it this way, it might help you decide which to do first, addition and subtraction or multiplication and division. So we have a height in feet of a tree after x years is 1.5x plus 15. After how many years is the tree 24 feet tall? Let's break this down and see exactly what this equation is trying to say. If you have a tree that, say, has been growing for 0 years, 0 years if we plug that in there. So we know that 1.5 times 0 is just 0. So what is 0 plus 15? That just equals 15. So if you have had 0 years that your tree has been there, it'll be 15 feet tall, otherwise known as you planted a tree when it was 15 feet tall. It from there begins to add on to how tall your tree is. Each year getting a little bit taller until we get 24 years. Now, to go backwards, we would first have to get rid of the 15-foot leap that it got. So if we were to subtract all of that, and then we were to factor out how many more, and then we can see how much feet is left, and we'll know how many years it grew from that point. So let's look at this equation. As they solve it, they first subtracted 15 feet from each side, just like we sort of cut off the bottom of that tree that was already grown. So 24 minus 15 is 9, and then they divided both sides by 1.5. And if you did your math real quick, you have the remaining portion of that tree, 9, when divided by 1.5, is 6. So that means the tree is 24 feet tall after 6 years. So planted that first 15 feet, and then it grew another 9 feet in 6 years. What's important here is first subtracting and then doing our division. In the second example, you'll see our very first step that we always do is simplifying. As the name of the example, combining like terms to solve an equation, otherwise known as simplifying. So let's first, they would write out the equation like I always like you guys to do in your books. And then they combined 8x minus 6x. So if you have 8 pies minus 6 pies, you only have 2 left. And then you have 25 other things. There are other things. They're not like terms, so this is as simple as it can get. Now, the very first thing we do, just like we did the trees, is let's get rid of the numbers, the things that are far away from the variable. The inverse operation of subtracting 25 would be to add 25 to both sides. And that just turns into 0, so we're left with 2x by himself down there. Now, don't be dismayed. If we have negative 35 on a number line, and then we are going to add 25. Are we going to make it all the way to 0? Not quite. We'll make it all the way to negative 10. It's another way to look at that. Lastly, divide both sides by 2. Negative 10 divided by 2 is negative 5. A negative divided by only one positive is just a negative. So our solution is 5. If we plug it back in our original equation, we can see that 8 times negative 5 minus 6 times negative 5 minus 25. Let's simplify and see if it equals negative 35. See, 8 times negative 5 is a negative 40. A negative 6 times a negative 5 is positive 30. And then minus 25 again. Negative 40 plus 30 gives us negative 10. Then minus 25 takes us all the way over to negative 35. And you can sort of see that on the bottom of the screen. There. That's what you missed out on. Please do on your own. And of course, I can help you in class, or we can just go over answers. It's much faster that way. The 1, 2, and 3. Remember, I would deal with the 1 first, deal with the negative 9 first, combine, and then deal with the positive 17. Also remember, how do we move fractions? Multiply by the reciprocal. This part may be the most confusing part of the lesson. So, we'll go slow to figure out everything that's going on. It's this pesky distributive property. Once we get used to it, you'll know exactly what to do, but we have to get used to it first. Now remember, distributive property is where you distribute a number throughout a bunch of parentheses. It's like if you bring cupcakes for class, you better bring enough for everyone or don't bring any at all. Now, here, in this very first problem, we have solve 2 times the difference of 1 minus 5 plus 4 equals negative 8. We're going to get x all by itself. In order to get there, it is a little bit of a process. So one way to do this, there's going to be 2, I'll show you the other one in a second, is to distribute 2 through. So we have 2 times 1 and 2 times negative 5x, or you can see they wrote that out here, and then we simplify. So 2 times 1 is obviously 2, and then negative 2 times 5x is negative 10x, and plus 4. Now always the first thing we do is we simplify. There's no other x's to combine, but there is a 2 and a 4 to combine. So negative 10 plus 6. Subtract 6 from both sides. So that gives us negative 10x by itself equals negative 14. Now it's okay to divide both sides by negative 10, knowing that it won't give us a whole number. Remember, a negative times a negative turns into a big positive, and we're left with x equals 1.4. A second way to do this is if you bring your attention over here to the study tip. If you wanted, what this study tip shows is you can deal with this 4 because it's so far away and not involved in any multiplying or dividing. And what they did is they subtracted 4 from both sides. That's how they got negative 12. And then they divided both sides by 2. Since 2 is on the outside, it's like that's a term and this whole thing is its own term. So when they divided by 2, it only affected this outside bit. So then the 2 goes away. Negative 12 divided by 2 is negative 6. We're left with 1 minus 5x. They subtracted 1 from both sides, which gives us negative 5x all by itself equals negative 7. And then if you divide negative 7 by negative 5, you get the same answer, 1.4. Everyone's favorite, story problems. We're going to use this real-life application, and hopefully things make more sense when we're done. Now, they want us to use this nifty table in order to set up a problem. Let's read our instructions. Use the table to find the number of miles x you need to run on Friday so that the mean number of miles, that means the average number, run per day is 1.5. So they tell us what the answer that is always a dead giveaway for what the answer is supposed to be. Now we need to set up an equation. So we know if we add up all the miles we run in a week and divide by the number of days, that'll give us an average per day of Monday through Friday. So that's what they did. They added Monday plus Tuesday plus Wednesday plus Thursday plus Friday, and then divided by the number of days, 5. And we want it to equal 1.5. We can make it equal 1.5 by finding whatever value x is that makes that true. So the very first thing we always do is we simplify or combine like terms, as they say, which is all the numbers. Those are all like terms. They don't have a variable next to them, so we just add them all up. So 2 plus 1.5 is 3.5 plus x divided by 5 equals 1.5. Now here is where things might get sort of pesky. You see how you can't touch this 3.5? Yes, we should be adding and subtracting things like we usually do, but we can't touch it because it's built in to this sort of fortress that's next to x involved there. But if we get rid of this 5, then we can get to the 3.5 unscathed. This may not make sense right now, but follow along and eventually it will, I promise. So we can multiply both sides by 5, undo that, and we effectively release the 3.5 plus x. When we do that, the rest is history. Subtract negative 3.5 from both sides, that cancels out, and we're left with x equals 4. So if we run 4 miles on Friday, then our average will be up to 1.5 miles per day. Please do the remaining 3 on your own. Let me give you some hints. You're going to want to use distributive property to get rid of these parentheses and then combine like terms or simplify. On number 5, you're going to want to do the same exact things. Knock down these parentheses with distributive property and then combine like terms again. And lastly, give yourself a chance to try to set this one up, and if you can't get it, I will give you the equation you can use to solve. How did that work out? If it didn't, here's what we can do. We know we scored on these 3 tests. However, we have a 4th test, and we want to make our score at least 90. So we know we need to add up all 4 tests and find their average, and their average has to equal 90. So this would look like 88 plus 92 plus 87, and then this mystery 4th test, which we can say is x. All of this is going to be divided by 4, because that's how we find an average, then equals 90. Now, if this is enough, I'd pause and see if you get the right answer. And we're back for more. So if we still needed a few more tips here, I can squeeze it in on the bottom of the screen. Add up 88 plus 92 plus 87 as our like terms. That gives us 267 plus x divided by 4. 4 equals 90. Now remember I said that we have to get rid of that 4 first. So let's multiply both sides by 4. Leave that to itself. It's 4 times 4. So then our equation, if you look over here, turns into the 4 simplifies. We just have 267 plus x equals 4 times 90 is 360. All we need to do is subtract. Minus 267 from both sides